Welcome to Understand the Math. In this video, I'm going to show you how to solve absolute value equations in a way that's easy to understand. We'll look at 3 different types of equations and go through examples step by step so that you'll know exactly how to solve these equations and how to check your answers. We're going to start by learning how to solve the most basic type of absolute value equation, where you have the absolute value of a linear function on one side and a constant on the other side. Equations like this will either have 2 solutions, 1 solution, or no solution. And I'm going to show you an example of each type. Let's first look at an equation that has 2 solutions. To solve this equation, we're going to have to split it up into 2 pieces. And the reason for that is that whatever is inside an absolute value can be positive or negative. Because of this, our problem is going to get split into 2 pieces. Our first piece is going to be when the absolute value is positive on the inside. That's going to be 4x minus 2, and we set that equal to 2. Or we're going to look at the piece where the function inside the absolute value is negative. So we write this as 4x minus 2 is equal to negative 2. Let's now work on our left-hand equation. We're going to solve for x, so let's take our constant to the right. So we add 2 to each side of our equation, and that gives us 4x is equal to 4. And then we're going to divide each side of our equation by 4. So we get the solution x is equal to 1. Let's now work on our right-hand equation. We're going to do the same thing. We're going to solve for x. So we're going to add 2 to both sides. This gives us 4x is equal to 0. Then we divide each side by 4, and we end up with the solution x is equal to 0. I always think it's easier for students to understand these types of equations if you can see it graphed. On the right-hand side, I have the graph of the absolute value of 4x minus 2. And our equation says that that absolute value is equal to 2. So let's draw the line y is equal to 2. And that's this line right there. The solution to this equation is going to be where these 2 functions intersect. And they actually intersect at 2 places. The first place they intersect is here. And if we trace down to the x-axis, that's where x is equal to 0. And then they intersect here. And that's at the point where x is equal to 1. So you can see that this example has 2 solutions. Let's now look at our second example. This is an example where we're going to have 1 solution. Since our right-hand side is 0, we're only going to have 1 equation, and that equation is going to be 4x minus 2 is equal to 0. And we'll add 2 to both sides. And that gives us 4x is equal to 2. Then we'll divide each side by 4. And we get x is equal to 2 over 4, which we can reduce to 1/2. Let's now look at the graph. We have the same absolute value function graphed. And now we're going to graph y is equal to 0, because that's the right side of our equation. So let's go ahead and let's graph y is equal to 0. It's actually right along the x-axis. And you can see that these 2 graphs are going to intersect at this point, which corresponds to x is equal to 1/2. So when we have an equation like this, and we only have 1 solution, it's where the vertex of the absolute value intersects the equation from our right-hand side, which in this case is just y is equal to 0. Let's now look at our third one. This is going to be an example where we're actually going to have no solution. Notice with this one that it says that the absolute value is equal to negative 1. The absolute value of 4x minus 2 cannot be negative, because an absolute value is always greater than or equal to 0. So we say that we're going to have no solution. And let's see if this makes sense graphically. Let's go ahead and graph our right-hand side, which is y is equal to -1. So I'm going to graph a line, y is equal to -1, and you can see from the graph that the absolute value function and this line never intersect. And because of that, we have no solution. Now that we have the basics down, let's do an example that's a little bit more complicated algebraically. That's example number 4. When you solve a problem like this, there's actually 2 steps that you can follow. So let me write down the first step. The first step is what you want to do is you want to make your problem, we'll write down, make it look like ax plus b is equal to k. So in other words, we're going to get that absolute value function on our left, and we're going to have just a constant on the right. So let's go ahead and let's do that. We'll start by writing down our equation, 3 times the absolute value of 4x minus 1 minus 5 is equal to 10. We're going to start by pulling our constants to the right-hand side. So we're going to add 5 to each side, and this gives us 3 times the absolute value of 4x minus 1 is equal to 15. And then we're going to divide both sides by 3. And we have absolute value 4x minus 1 is equal to 5. Now we can go ahead and solve this just like we did in our first example. So I'm going to put a little 2 over here. So this will be our second step, is to solve it. We're going to solve it by breaking it up into 2 pieces. The first piece is going to be our positive piece. So we have 4x minus 1 is 5. And then we'll put a little or. And then we have our negative piece. 4x minus 1 is minus 5. Let's go ahead and let's add 1 to both sides. We're going to work on the one on the left first. So this gives us 4x is equal to 6. Dividing both sides by 4, we get x is 6 divided by 4. Notice that 2 goes into both of those, so we can reduce this to 3 divided by 2. Now let's work on the one on the right. We're going to add 1 to both sides. So we end up with, we're kind of running out of room here, 4x is equal to minus 4. We're going to divide both sides by 4, and we end up with x is equal to minus 1. Let me go ahead and highlight both of those answers. So our first answer, x is 3/2, and our second answer, x is going to be equal to minus 1. I want to make a note that you can always check your answers. Mathematics has so many nice built-in checks, and this is one of them. What you can do to check your answer is substitute x back into the equation. I'm going to just check one of these answers, and I'm going to check the answer -1. Checking 3/2 will be just the same. So over here on the left, I'm going to plug -1 back in to our equation. Plugging x is equal to -1 back into this equation gives us 3 times the absolute value of 4 times -1 minus 1 minus 5. And this is 3 times minus 4 minus 1 minus 5, which gives us 3 times the absolute value of minus 5 minus 5. The absolute value of minus 5 is just 5. So this gives us 15 minus 5, which is equal to 10. And this 10 agrees with this 10. So we know that we have found the correct solution. Let's now look at some examples that have an absolute value of a linear function on the left and one on the right. These types of problems can either have infinitely many solutions. That's going to happen when A is equal to C and B is equal to D. So that doesn't really happen. You would never really solve a problem where you actually have 2 of the same functions set equal to each other. But it can happen. Or you can have 2 or 1 solutions. The most common number of solutions is going to be 2. And both of the problems that we're going to look at have 2 solutions. Let's go ahead and let's look at our first one. We're going to do it just like we did with the problems on the previous page. We're going to split it up into two pieces. Our first piece looks like this. We have x minus 2 is equal to 1 minus 2x. That's our positive piece. Or we can have x minus 2 be minus, and you have to be very careful with parentheses here. We're going to put a parenthesis here, 1 minus 2x, because the negative is going to have to distribute to both of those terms. Let's go back and let's look at the first piece, and let's work on that. We'll start by getting the x's to the left. So we're going to add 2x to the right and 2x to the left. This gives us 3x minus 2 is equal to 1. Now let's pull our constants to the right. So we're going to add 2 to the left, add 2 to the right. We get 3x is equal to 3. Now let's solve for x. So we divide both sides by 3, and we end up with x is equal to 1. I'm going to go ahead and highlight that solution. Now let's work on our second piece, the one on the right. The first thing we want to do for this piece is let's distribute that negative that's on the right-hand side. This then becomes x minus 2 is equal to minus 1, and then we have a minus negative 2, so that becomes a plus 2x. Now let's go ahead and pull our x's to the left. So we're going to subtract 2x from each side. This gives us minus x minus 2 is equal to negative 1. Now let's go ahead and let's move our constant to the right. So we're going to add 2 to both sides. This gives us minus x is equal to 1. And then the last thing we have to do is divide by negative 1 on both sides. So we end up with the answer that x is equal to minus 1. And that's our second answer. Let's now do another one. You may want to pause the video and see if you can do this one on your own. I bet you can. I'm going to start with breaking it up into pieces. So I'm going to write our first piece, which is 2x minus 9 is equal to 8 minus 3x. And then we have an or. And then our negative piece, 2x minus 9, is equal to minus, watch those parentheses again, 8 minus 3x. Now let's return to our first piece and let's solve that. I'm going to pull all the x's to the left. So I'm going to add 3x to both sides. This gives us 5x minus 9 is equal to 8. Now let's pull our constants to the right. So we're going to add 9 to both sides. And we get 5x is equal to 17. Now we need to get x by itself, so we divide by 5. And we end up with an answer that actually doesn't look very nice, but it's correct. X is equal to 17 divided by 5. And I'll go ahead and highlight that. So that's one answer. Now let's go back up to the top here, and let's do our second piece on the right. First thing you want to do is distribute the negatives. So our left-hand side is going to stay the same. And on our right-hand side, it's going to become minus 8. And then we have a minus times a minus 3 gives us a plus 3x. Let's now pull our x's to the left. So we'll subtract 3x from both sides. This gives us a minus x minus 9 on the left and a minus 8 on the right. Let's move our constants to the right. So we're going to add 9. And then we have minus x is equal to 9 minus 8, which is 1. And then again, we're going to divide by negative 1. And then that gives us our final answer. X is equal to minus 1. And let's highlight that. This absolute value problem had two solutions, and they were 17 over 5 and negative 1. The last type of examples that we're going to talk about are examples that have the absolute value of a linear function on the left, and then just a linear function without an absolute value on the right. I think these are the most complicated type of absolute value equations you can solve. These equations can have infinitely many solutions, just like we saw with the previous examples, or they can have 2, 1, or no solutions. The reason that these problems are more difficult is that when you get your answer, you have to do one more thing, and you have to check your answers and see if they're what we call extraneous solutions. Extraneous solutions are solutions that you get when you solve a problem, but they're not actually solutions. And I'll show you exactly how this works. Let's start with our first example. We're going to do it just like we've done all the other examples in this video. We're going to break it up into two pieces. Our first piece is going to be 2x minus 1 is equal to x plus 2. And then our second piece is going to be 2x minus 1 is equal to minus x plus 2. Let's work on our first piece. Let's bring our x's to the left, so we subtract x. This gives us x minus 1 on the left and 2 on the right. And then let's solve for x, so we're going to add 1 to both sides, and we end up with x is equal to 3. Let's put that in our pocket for a minute, and we'll come back to it after we find our other solution. Let's go over here to the right and look at this piece. The first thing we're going to do to solve this equation is distribute the negative. Our left-hand side stays the same, 2x minus 1, and then we distribute our negative on the right, so we have a minus x minus 2. Now let's pull our x's to the left, so let's add x to both sides, and that gives us 3x minus 1 is equal to minus 2, and then we'll add 1 to both sides, so we have 3x is equal to minus 1, and then we'll divide by 3, which gives us x is equal to minus 1/3. Now, we don't know if these solutions are actually solutions, so we're going to have to check them. So let's write down that we're going to check solutions. Let me show you how to check them. Let's go back up to our problem, and I want to highlight the right-hand side. Our right-hand side is equal to x plus 2. On our left-hand side, we have an absolute value. An absolute value can't be negative, and it has to be greater than or equal to 0. To check our solutions, we have to know that our right-hand side, x plus 2, has to be greater than or equal to 0. So that means x has to be greater than or equal to negative 2. Now we're going to go back up and we're going to look at both of our solutions and see if they're greater than or equal to negative 2. Let's look at our first one. Our first solution is x is equal to 3. 3 is definitely greater than or equal to negative 2. So let's put a check here. That is a solution. Now let's look at our second one. X is equal to minus 1/3. Minus 1/3 is also greater than or equal to negative 2. So this is also a solution. This is an example of a problem where we had two solutions. Now let's go on and let's do one more example. And this is going to be an example where we're not going to get two solutions. To solve this example, we're going to do just like we did with all the other ones. We're going to split it up into two pieces. Our first piece is x plus 2 is equal to 3x minus 2. And then our second piece is x plus 2 is equal to minus 3x minus 2. Let's work on the first piece. You know the drill by now. Let's pull our x's to the left. So we're going to subtract 3x. This gives us a minus 2x plus 2 is equal to minus 2. And now we're going to pull our constants to the right. So we're going to subtract 2 from both sides. On the left, we have minus 2x. And then on the right, we have a minus 4. Let's give us a little bit more space here. We're going to divide both sides by minus 2. And this is going to give us x is equal to 2. Let's put that in our pocket for a minute. We're not going to check it yet. And let's go ahead and let's work on our right-hand equation. The first thing that we'll do is distribute the negative on our right. So this becomes a minus 3x, and then minus negative 2 is plus 2. Now let's bring our x's to the left. So we add 3x. This gives us a 4x plus 2. on the left, and then we have a 2 on the right. Now we're going to pull our constants to the right, so we subtract 2, and this gives us 4x is equal to 0, and then we just divide both sides by 4, and we get the solution x is equal to 0. Now we get to check our answers. Let's go ahead and let's highlight the answers that we're going to be checking. And then now we can look at our right-hand side. So let's just put down that we're going to check. Our right-hand side, 3x minus 2, has to be greater than or equal to 0 because our absolute value has to be greater than or equal to 0. Now we get to solve for x. Let's add 2 to both sides. So this is 3x is greater than or equal to 2, which gives us x is greater than or equal to 2/3. What we have to do now is go back up to our solutions and see if they are greater than or equal to 2/3. X is equal to 2, definitely greater than or equal to 2/3, so we'll put a check. That is a solution. And now let's look at x is equal to 0. 0 is not greater than or equal to 2/3. It's less than 2/3. So we're going to put a red X here. This is not a solution. So this was a problem where we had an equation that has only one solution. And the other solution that we thought was a solution is actually what we call an extraneous solution, and it's not included because it's not actually a solution. I hope you now feel more comfortable solving absolute value equations. What you need to do now is maybe rework these problems on your own and then also work some additional problems until you're comfortable solving these types of equations.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.